All right, so hello and welcome. Here we are, another question. This is going to be number 1282. Group the people given the group size they belong to on LeetCode. Let's take a moment, make sure the audio is working. Number 1282 is working, very good. Okay, so this one here. This one I did. Close that one. Oops. Oh no, do that. And then just refresh this one while it's going. Okay. All right. Group the people given the group size they belong to. There are n people that are split into some unknown number of groups. Each person is labeled with a unique ID from 0 to n-1. You are given an integer array group sizes, where group sizes of I is the size of the group that person I is in. For example, if group sizes of 1 is 3, then person 1 must be in a group of size 3. Return a list of groups such that each person I is in a group sizes of I. Each person should appear in exactly one group, and every person must be in a group. If there are multiple answers, return any of them. It is guaranteed that there will be at least one valid solution for the given input. Okay, I don't really know what they're describing, but I can try to understand. First group is 5, size is 1, and group size of 5 is 1. So is 1, I'm not sure I understand. Second group is 0, 1, 2, size is 3, group size of 0 is 1, 2, 0, 1, 2 is 3, 0, 1, 2 is 3. Third group is 3, 4, and 6. 0, 1, 2, 3, 4, 5, 6. The size is 3. The group other possible solutions are 2, 1, 6, 5, 0, 4, 3, 5, 0, 6, 2, 4, 3, 1. I don't understand what they're asking. Size of the groups are size n, and the group sizes are less than or equal to n. Very high acceptance rate, pretty high submission rate. Yeah, high acceptance rate and submission rate. So this seems to be kind of an easier question. N people that are split into some unknown number of groups. Each person is labeled with a unique ID from 0 to n-1. Okay. Integer array group sizes, or group sizes of I, is the size of the group that person I is in. Oh, I see. Okay. So this person is in a group of size 3, 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 group of size 1, group of size 3. Okay, I understand. Okay, got it. A list of groups such that each person is in a group of that size. Oh, okay. Each person should appear in exactly one group, and every person must be in a group. If there are multiple answers, return any of them. It is guaranteed that there will be at least one valid solution for the given input. Okay, that's interesting. All right, probably an easy way of doing this is just to create a key. Okay, the group sizes, size n. Yeah, so because there's only 500 elements that we're dealing with, I can use a frequency map and count how many elements, how many people are in groups of size 3, right? And then I suppose what I would do is easier than that is just have a vector of groups for each group size. So for group size of size 3, right, I would create a vector, and then when I see a 3, I push that index into that vector, and then I see another 3 and push it in, and another 3 and push it in. Now it's size 3, I create another vector there. So it would be a vector of vectors, an array of vectors of vectors. And then I would just do the same thing when I see 3, push those 3s there, and so I would get 0, 1, 2, 3, 4, 6. In those vectors, those arrays, and then I'd also get a 1 for 5 in that array. And then at the end, I can just collect all of those vectors into another vector of vectors. Yeah. We'll just say VV frequency, or just by key. I'll just say by key. And it's an array, actually. Constants bound. All right. Fill this by key with empty vectors of vectors. Something like this, empty vectors of vectors. So I could do that. Now I can say const x in group sizes. I can say by key of x dot push back x. So if, let's say VV. I did that wrong actually. I want to push back I and index I. Yeah, I want this index. Oops. Actually, this bound could be n, same thing. So I think they're both. Oh no. Wait. Yeah, I think everything is bounded by n. It could be less than or equal to n. Yeah, I think I just set the bound n plus 1. Yeah, because this could be equal to n, right? Actually, never mind. We'll just do it. It's fine. Well, yeah, okay, that's fine. A little confusing, but it's okay. All right. X is going to be group sizes of I, right? VV is going to be by key, and we're going to say VV.pushback I, and we'll say if VV.size is greater than or equal to X, then we're going to say VV.inPlaceBack. It's actually going to be VV.back.pushback. And probably easier thing to do would be to say if VV.size, if VV.empty, or VV.back. Yeah, that's probably better. And then create a vector at the back of VV, an empty vector, and then put the element there. And then at the end, we're going to just collect all of the result. I don't know how many groups there are going to be. I guess I'll just reserve n. It's probably fine. All right. I is 0. I is less than bound. Increment I for each auto reference vector in by key of I, and we'll say const auto VV is by key of I, current V. It's also going to be const auto. And then we just say result.pushback a copy of current V. Something like this, something along these lines. It's not too, I don't know, the way that I programmed it's maybe a little bit complicated. Do I need, can I just do this? Do I need, template parameter, ignore substitutions. Oh, this shouldn't be const. Oh, whoops. Yeah, I don't know why I made that const. This shouldn't be const. Okay. Also, this should be vv.back.reserve x. After it's been placed. That's also true. Okay. I'm gonna go for it. Just gonna go for it. Could be wrong. Could be make a mistake somewhere. I do in 10 minutes. Okay, got it. Sweet. All right, I'm gonna submit this 4 more times. Hopefully it makes sense what I did. I didn't really explain too much. I'm gonna submit it 4 more times, and then what we'll do is I'll say I'll stop the stream on this question and then start a new question. And if you like this video, give it a like and subscribe for more. Hopefully that was relatively easy to understand what I did. 1, 2, 3, 4, 5. Use something of a frequency map, a key. Excuse me, to associate the values with their respective groups. 1, 2, 3, 4, 5. We'll do one more submission. It's reasonably fast. It's not the fastest, but it was almost 100% on one of those runs. So it's okay. It's okay. It uses a significant amount of memory, it seems, but that's okay. I mean, the way that the question is asked, it's going to use a lot of memory anyway. Not a lot of memory, but a considerable amount of memory for the output anyway. All right. So yeah, thank you for watching, and I'll start another question. Take care.